want to, the title of this talk is Visual AI, Linguistic Intelligence, and this is largely generated by the interest that's developed in generative AI. And we're going to specifically talk a little bit about how to understand this generations of AI in terms of what's called steerability and composability. But really, if you want to think about it, we want to investigate how creative can we describe the machines. And I think this is something that immediately causes some confusion or tension among people because we assume the machines are inherently mechanical. And I think it's an interesting phase of sort of human society where you begin to question that presupposition. So it's an ambitious title, but I think I want to show it to you in terms of stepwise so we can kind of grow together on it. If you think of the human brain, the small inset here is sometimes called Broca's brain. Different neurologists think this is the origin of language, or it's certainly highly stimulated when you speak. And so in some sense, if you were trying to localize, the visual cortex is in some sense, visual AI and linguistics lives here, and this separates us from other species. So the outline for the talk, let me shrink this. The outline for the talk is we're really going to design a practical multi-step sort of recipe in terms of visual reasoning. I'll describe to you what multimodal language models are, sometimes called large language model or LLMs. You're probably familiar with that through ChatGPT or Google Gemini. And then, of course, this layer that's come on strong in, say, the last 4 or 5 months, which is combining vision with language. So multimodal models, or in some sense called visual language models. And essentially, they work after being trained on many examples. They work by converting pixels to tokens and eventually can generate text or describe what's being seen or even take your instruction and generate it. So the intriguing elements of this, which really make it useful to people, are how steerable is it? By steerability, I just mean, does it take direction? So if I give it, I want a stick figure of a boy running in a field, and it draws me a cow or a horse, then that would be considered a failure in terms of steerability. So how does it do what we tell it to do? The other one is composability, which really is kind of the flexibility of its instruction set. And I think this is the part that's so remarkable when you think about if you had to sit down and write the program to, say, draw a CAD drawing, a three-dimensional picture of a house. The composability instructions of that would be incredibly complicated. And once you went to another style of house, you would have to change those rules. Well, composability is basically, it's kind of a measure of creativity, but it's also, it's a combination of, does it do what you tell it to do, and does it have some flexibility? And really the essence of what I think has captured people's imagination about these language models and visual models is really kind of the basic notion that it has some memory and context. So if I ask for a series of Lego pictures in 3 colors, 5 colors striated like the rainbow, and I'm not happy with that image, I always have the ability to go back to the AI and essentially continue the session. And I think that memory and context, when you think about how these things are trained, is the truly expensive part of running a large language model. So the goal is to develop an experimental test suite. We're going to actually go through a series of examples of creative, diverse construction. Composability is sort of the diverse, and creative in some sense is our steerability. And that range we're going to go through will begin with kind of the simplest version of kind of construction, where you have an artist palette like Legos, and you will build up various scenes, to more complicated practical things like satellite image analysis. And in total, the paper, as well as this presentation, really has about 800 or so guided dialogues. And the idea is to rank those tasks, so-called creative tasks, by difficulty. So gameplay may be hard, give me a recipe may be easy, and we want to somehow score current capabilities. So, as the field advances month to month, we can get a sense as to what its progress is. So what is generative AI? Here's a very quick example. This uses Midjourney, which is a text-to-image generator, and you simply ask it, imagine, and something, kind of off the wall would be a red frog on a green lily pad. It does a very nice job of capturing something that really could not have been in its training data per se. And so that has a high steerability and to some extent the flexibility to not just memorize, but to generalize. Is an example of composability. Now you can reverse this and feed this image back into a text generator. In this case, you would ask the question, what is this? And you're essentially doing the captioning of that image. And so now we push this from Midjourney to ChatGPT Vision, and it says the image of a red frog sitting on a green leaf, and then it gives some insight into the nature of the frog skin, the details of the natural setting, water droplets, the slit on the eye, all the things. In some sense, if you look at many AI-generated images, it always has trouble counting. You can think of that as it's not a calculator, it's a language model. So you might see more fingers, eyes or pears or ears can be difficult. But anyway, this is a pretty good version and it's evolved. I think this is version 6. So I want to talk a little bit about kinds of creativity because I think it's worth considering. I think everyone assumes that creativity is absent from that, and that still remains our realm as a species. And so I want to talk about really 3 kinds of creativity. One is you call it deliberative, which means you kind of set out on a task and you complete it in a somewhat novel way. So this could be a combination of dissimilar ideas. If I ask you, combine cryptocurrency and climate change, you could probably come up with a plan in which people get paid to not pollute. And that would be a kind of combination of, in some cases, dissimilar ideas. But if they're a combination of similar ideas, I think we tend to think it's not as creative as combining two different colors, for example. If you're thinking about it in a game sense, that's an AI that can play a move. The other one is, I think, the one that I think causes people concern because we know these are computer programs. There's a mechanical element to it. So the part that we still might hold in reserve is what you call spontaneous creativity. So this is, the apple falls on Newton's head, and through that action, through that sensory input, the metaphor goes that he discovers gravity. In this case, it's triggered by some sensory input or inspiration. In our case, it could be triggered by a prompt saying, ask for a red frog on a green lily pad. And you can imagine this is more like creativity in terms of I've devised a whole new strategy to play chess. I'm not just playing a single move. I'm going to give up all my pieces to clear space, and then I'm going to sweep in with that mobility at the end and win. So that would be a novel game strategy to go deep in the hole in chess and then come out victorious. And that would be a kind of spontaneous. And one of the reasons why I think people reserve this for humans is the fact there's a strong sensory input. I'm still giving it the prompt. It's not sitting there just churning on coming up with creative ideas. And the last one, which is really the pinnacle of this hierarchy, is what we would really call truly original. So that means I'm not going to play chess. I'm not going to build a new strategy for chess. I'm actually going to design chess 2.0. So design a game is the thing that we would call, maybe it's emotional and spontaneous in the sense it truly looks like the lightning bolt, but this is what we have traditionally viewed as artists and musicians. And in some sense, the original idea of this robot was it's going to replace factory workers, and I think it's now commonly thought, creative jobs are more at risk than we thought. So this is part of the introduction of the paper and really frames the question we're asking. And when ChatGPT was released, Psychology Today advised teachers, from an instructional perspective, the multiple choice test is dead. Essentially, the machine can do it better than we can do it. And so you should, as a teacher, focus on assessments that reward creativity or apply knowledge in specific contexts instead of just going to accuracy. So it would kind of be like if in the old days, if you gave students a calculator, you would not ask for strict multiplication and addition. You would give it as a word problem, which required the student not just to test the accuracy or speed, but in some sense to really understand the questions being asked. So that is a kind of challenge to the proposition of this paper, which says creativity may not be as sacrosanct as we think. And in fact, that's really what has come out if you follow OpenAI's, discussion of did it come for blue collar jobs, white collar jobs, or in some sense they're called black turtleneck jobs, meaning more creative artist people, not even wearing white collars. And OpenAI's Sam Altman said creativity has actually been easier for AI than most people thought. So that's kind of part of the inspiration for this talk. So how would you address this in a practical, scientific, metric-driven way? So there are these categories which are what LLMs, large language models, and vision language models fail at. And so this is kind of a catalog of mea culpas from OpenAI. Don't use it on medical images. It tends to be weaker on non-English. It can get confused if there's big text. In other words, it's been trained kind of on traditional size text within the page. It doesn't do well on rotation. Some visual elements like dotted lines may confuse it. If you give it a chessboard, spatial reasoning can be difficult. So like positions on the board, it tends to hallucinate very strongly there. Fisheye lenses, resizing of images, counting, and captcha. So that's a kind of things not to do, or if you saw them in the wild, you would say that was a real accomplishment. So this is a kind of graphic version of the horrible image to feed a vision language model. It includes all those malformed versions of AI content. You have some medical pills here. You have a certain kind of strange fisheye perspective. You have multiple objects in the frame, so counting. There's also some rotation of text here. A lot of what appears to be non-English, although it's probably gibberish. And then, of course, the combination of big, small, and multiple objects. But if you think about this as AI hard, this also is, there have been whole art movements surrounded around these kinds of combinations. So clearly humans can find this creative even if AI can't crack it. So one of the challenges of metrics in this context is, if you're asking for accuracy, we can test that easily. We can develop benchmarks. But if you're talking about true generative AI, it's like the essay question versus true false. A human typically grades that. If you're an art critic, some people may like this, some people may not, and of course the scale of it. So that leads us into the composability argument. This is an example of AI-generated art from Legos. So build me a bridge. So it takes that instruction, and then the composability is how good of a bridge is that, does it have the other components you would hope to find in a bridge construction? So let's go through a couple quick examples. I want to do a logical progression just to illustrate almost you're going to make the movie of a scene, and the more emotional content, the more originality, the better. So we're asking, here's a stack of Legos, identify them as Legos, and then redraw that image with action. And the action should be this figure we're going to create out of this sort of set of ingredients. And then we're going to ask it to add a component, a twist, which in some sense is completing the thought. And you can think about the way these are trained as next token predictors, that essentially this sequence of pixels may predict the pixels around it, but it's a bit of a different question to ask it to leap to, and he falls back in his chair. And so we want to shuffle these images and see what kind of changes we see in the large language model. But the essential kind of way we're hello, so I'm getting some feedback. Anyway, the way we're constructing this is really from piece parts to a complete view. So these are, in the paper, we go through 14 different curated tasks. We begin with Lego designers. We go to some challenges in aerospace. We'll really iterate this image to ingredient. So we can ask it to be a bartender, a chef, or a salad chef. We can ask it for essentially the user manual for all different kinds of things. So you can imagine origami or repairing broken objects and all the way down. And we really think about this in two combinations. Image to instruction, I think, is a useful skill. And then stepwise, how can you construct it stepwise? Show your work, if you will. And then in a somewhat subjective way, but also in terms of the results, you can begin to predict the completion difficulty. So let's go through these kind of rapidly. I think they're easy to grasp, but you would ask it, draw the instructions for making a paper airplane. So in stepwise, you get some folds, you get some more folds. It seems to understand this, that you're giving someone instructions with dotted lines, and eventually come up with a relatively original design. So that's high in both steerability, it took the direction, and composability, meaning it's not a simple design by any stretch. And you can imagine the usefulness of that sort of creative input. The other version is I would just give it this and ask it to deconstruct it. And I think that's another version of creativity. Here's another version of progression from decomposition to recomposition. So we begin with an origami swan. We ask it to transform it into a peacock, and then we ask it to color the peacock. So it's sort of decomposition to compositing, but it is really that composability that is quite remarkable when you think about it. Another one is from one conception of object to a completely different conception. I know a lot of architecture studios will do this, where they'll give you, say, a model, a plastic model for a car, and ask you, take those piece parts and make something totally unrelated to the car. So we wanted to test that. So we asked for a car with wing doors, and then we convert that to a flying car, essentially converting the wing doors to true wings. And then we ask it to do the difference between those two images. So an interesting version of this is really the classic deliberative creativity. It is following instructions, but you are giving it an end goal. It's not particularly spontaneous, but still remarkable. This is a kind of familiar thing for people who are used to generative adversarial networks, or GANs. It's called style transfer. So in the first case, given these ingredients, construct a salad for me. You're going to be a salad chef. Now take this image and put it in this form of Mona Lisa. So we've style transferred. Again, very high quality steerability. And then we're going to take this and convert it to a famous Italian artist, Archibaldo, who actually painted in the form almost of still life with vegetables. So this would be part of its training set. This would definitely be outside of its training set, but it does seem to capture both composability and steerability. If you think of the classic user manual problem, I think this is a famous version where you would take the chair we showed as Legos before and ask it to copy the style of IKEA, which, if you're familiar with furniture construction, is largely a series of building blocks and very complicated instructions. And it does kind of get a modern minimalistic look, and in some sense takes the Lego concept to, again, more of a deliberative kind of creativity. This one is kind of interesting. Again, something not really possible to be seen in its training data. We asked for the design of a data center inspired by Rubik's cubes. So the Rubik's cube is, the series of rotating cubes. It does a nice job with that, and you can then take that version and stretch to a light theme. So go from dark theme to light theme. And then finally, you can give it instructions like, I actually want it in a web design that has to be colorblind neutral. So essentially, that's telling the model, take out, sort of reds and greens. In some sense, it does get the colorblind theme as well. But the basic notion, would be what I would call the classic creative mashup, taking two dissimilar objects, a data center, a Rubik's cube, and give me an architectural design. I mentioned AI bartenders. It's pretty good at this, but you're asking almost as a detective. I will give you a picture of a bar, and you must identify what's in it, and then you must give me a new drinks recipe. So this is the prompt. You give it some steerable instructions, and it comes out with, in this case, a whiskey sour twist. You can continue, because of the memory and the context, you can continue to probe it to ask, where do you see certain ingredients in this picture? But again, you're essentially reverse engineering from an image to a recipe. Can do the same thing with the chef. Here's a picture of my refrigerator. This has become a common game within AI image generation and captioning. Analyze these ingredients somewhat practically, tell me what to go get at the store, and it comes up with chilled pasta salad. I can then, I think a very interesting part of creativity is often the novelty is from a constraint. It's not really this wild open universe you're describing, but the real creative touch is, put it in a picture frame. And so in this case, we ask, I'm actually going to lunch, so generate it in a packable lunch. So in other words, take these ingredients, recognize them, give me a recipe that doesn't require cooking, and then pack it for me. So the constraint makes it, I think, creatively harder. The last two examples here, I think there's considerable interest in the data science community to make dashboard builders or HTML. This is an example where you're given a sales inventory, and it turns out you ask for, give me a dashboard, analyzing the sales this month, and it will come out with it knows to rank the quantities and the prices and the price versus quantity and the distribution among the items. So it's not all just generate fine art. It can be data science art, if you will, in a practical sense. And I think the last example here is similar to what we did with the before and after picture. There are real practical images, practical applications here, one of which, here's two satellite images. This is a boat marina before a hurricane, after a hurricane. You want to ask the model, analyze these two images, count the number of boats, assess the damage, score any changed positions. And then you finally want to ask it to highlight the change from here to here, with red showing something that is gone. So in some sense, it initially goes from here to here and marks a lot of it as gone, meaning this image, we lost some trees, so those trees go red here. And then finally, you can push it to exaggerate the differences. So blue, sometimes in satellite world, blue is new, red is fled. So if some, say, a boat washes into the marina, it would be highlighted as blue, and it looks at this sort of sand bar as somewhat new and scores it. So pretty sophisticated behavior, not necessarily creative, but certainly analytically interesting. The last thing, which I think is fascinating, is you can, now that these models take voice input, you can take two phones, launch them, and have them converse while you are in the audience. So this is a game self-play. It doesn't involve a lot of imagery, but you're asking it to project off of itself. So in some sense, in the creative self-consciousness, there's often something called a mirror test, where an animal is placed in front of a mirror, and if it recognizes that it's talking, that is what it does is the mirror does, and that's a moment of self-consciousness. In this case, we're kind of pressing that analogy. We're going to play 20 questions. This one will be asking the questions. This one knows the answer, and they will generate this whole script about essentially trying to derive that the 20 questions is a measuring cup. So in conclusions and interesting areas for future work, we are interested in probing new ways of thinking about the creativity of these models. I don't think it's, as these models get better and better, I don't think it's going to be obvious to people that there are out-of-bound tasks. The notion that it can't do what we do, I think, may prove thinner and thinner. It has well-known shortcomings, and in some sense, we understand the reason for those shortcomings. So, for example, its training data, particularly on the language side, is very English dominant. Medical images, part of that is perhaps the lack of training data, but also the importance of getting it right. So if you want a sort of sliders that says, please be factual, please be creative, you want to have complete control over that. And so composability and steerability eventually evolve into something like a web slider that says, be strong on steerability and tone back the composability. Image to instruction looks very useful. I don't know how much of the world is plagued by bad instruction manuals, how much of IT is dedicated to generating regulatory documentation. But image to instruction looks incredibly useful, particularly when you think about how manufacturing is often done in foreign countries, from where the user is, and the user can't really make the same leap, but you could have a strong AI that could do that. Finally, I think the notion of simultaneous image and text. So a lot of the emphasis here has really been on stepwise, how does it follow instructions? Can it show its work? But I think when you think of spontaneous creativity, it's really that simultaneity. The apple hits Newton while he's thinking of gravity and generates an equation. And that kind of combination of lightning bolts seems really interesting. So a simple cartoon of that is you could have a vision model that analyzes, say, a photo or a piece of art, and the language model provides some derivatives or historical context for that. And then that text spawns the next generation of a new image. And how simultaneous that can be done, even when you go back to the human brain in terms of Broca's brain and the vision in the back of the head and language in the left side of the head, however true that is in practice, that still has a sense of simultaneity that makes it most interesting. So with that, I'll open it for questions. Thank you very much for your attention.